Hello, I'm John Stoneman, and I will be presenting on the topic of resin drying technologies. So what is the purpose of drying our resin? Most of the polymers that we use in the lab collect moisture from the air that coalesces on or inside the pellets themselves. Hygroscopic, or polar, materials tend to absorb some moisture into them due to the material and water having strong secondary forces. Processing resins with moisture present causes hydrolysis, the chemical breakdown of a compound due to a reaction with water. This is akin to thermal degradation. This causes various part defects such as streaks, bubbles, burning, or brittleness. Below we have polyvinyl alcohol, a hygroscopic material due to this oxygen atom creating a strong dipole moment along this bond. Next to it we have polyethylene, which does not have a strong dipole moment, and as such is a non-hygroscopic material. There are four fundamental factors to drying material. First is the temperature of the dryer, which controls the rate at which water molecules are released from the material. This is done by exciting the water molecules to break their secondary bonds to the polymer chains. As these water molecules are freed from the material, they are pulled into the surrounding air. This is due to our second factor, the relative humidity or dew point of the surrounding air being at a lower humidity than the material. Next, we want to move the moisture out of the dryer using airflow through the system. This removes the humid air from the hopper and introduces dry air back in. Faster airflow leads to quicker cycling of the air at the expense of drying efficiency. Finally, we have drying time. This is the overall time allotted for the material to dry. Now that we know the fundamentals of drying technology, we can move on to the two different popular types of dryers. First, we have the basic and the most common type of dryer, the hot air dryer. This dryer works much like a hair dryer in the fact that it only blows hot air over the resin that it's drying. As such, it only works well for nonpolar resins as the water molecules only condense on the exterior surfaces. It does not have any kind of control over the humidity of the dryer itself. That's where the second type of dryer, the desiccant dryer, comes in. These dryers utilize desiccant layers to help pull more moisture out of incoming air to reduce the dew point in the dryer. Because the dew point is much lower in a desiccant dryer, polar or hygroscopic materials can be effectively dried. On this slide we have a diagram of a dryer system. This dryer has a cooling system built into it to avoid damaging the desiccant layer below. This cooled air also goes through a filter to remove any possible contaminants and feeds into a blower. This blower sucks air through and out into the desiccant and finally into a heater. This heater heats up the air so that it can be blown over the material. The fundamental factors are controlled by various parts of the drying system. The heater bands below here, they control the temperature and is usually able to be tuned to the material that is being dried. The desiccant over here controls the relative humidity of the dryer, and it's based on the material that the desiccant is made out of. Next we have the blower. The blower controls the airflow through the system as it pulls air in through the back and out into the hopper dryer. As for the drying time, it is controlled externally, or if there's a timer integrated into the dryer itself, then it will control it there. That has been my presentation on resin drying systems. Thank you for listening.